Ladies and gentlemen, distinguished guests, welcome to Huawei Mobile World Congress Shanghai Online. The theme of today's summit is building data-centric converged storage solutions for all scenarios. Data has become a core factor of production. Effectively managing mass data has become a new topic for decision makers. Huawei aims to build data-centric converged storage for all scenarios, which can reduce TCO and improve resource utilization and management significantly. In the next hour, 3 experts will share with us about the details. So to kick things off, we're going to hear from Mr. Kendall Chilton, CTO and head of the FutureWay Storage Labs. His topic is Telco IT Data Infrastructure Insights. Please welcome Mr. Kendall Chilton.
Hello everyone, and welcome to the summit. My presentation today will focus on Telco IT Data Infrastructure Insights. As humankind has developed from the agricultural economy to the industrial economy and then to today's digital economy, the factors of production have also changed, from land and labor to capital and technology to data. In fact, data has now replaced oil as the world's most valuable resource. Presented as information, data produces commercial insights and values. IT infrastructure consists of 3 parts: compute, storage, and networking. Storage is where enormous amounts of this valuable data resides, so it is an important part of the IT infrastructure that deserves particular attention. Telcos have evolved from network operators to network plus cloud plus AI operators. We can classify telco IT systems into 3 domains to help us gain insights into their development and requirements. The production domain is the first domain. Systems in this domain provide production services for intelligent connections and are used to increase the ARPU and overall revenue. BSS, OSS, and video systems are usually assigned to this domain. The second domain is called the analytics domain. Based on telco's data, systems in this domain provide analytical services to help telcos improve internal efficiency and realize data monetization. This domain typically includes big data platforms and AI applications. The last domain is the innovative 2B domain. As the name indicates, systems provide innovative services in this domain to help expand 2B services and seize business opportunities. This domain includes both innovative cloud-native platforms and 2B applications, including big data, AI, and HPC applications. BSS is an important system in the production domain. One of its major functions is to help keep track of every user's data usage and implement charging and billing functions. Let's look at Carrier L as an example of how BSS is evolving. They hope to quickly deploy 5G services to seize market share and increase the average revenue per user. According to their statistics, 5G will boost data usage by over 3 times and the ARPU by more than 44%. As such, 5G brings additional load for L's BSS systems. When we look at the capacity requirements of 1 million subscribers moving to 5G as an example, the data volume will grow by 7.5 times, while the latency must be reduced to 1/8 of the original 4G. Therefore, it requires extremely high performance, reliability, and scalability to accommodate this data surge. To be specific, the latency needs to be reduced from 4 milliseconds down to half of a millisecond, while also supporting the transactional rate increase that the BSS applications will demand. Reliability must also be improved from 5 nines to 6 nines or even beyond, as minutes of downtime each year can no longer be tolerated. The solution also must non-disruptively and economically scale over this wide range and be able to handle further increases as Carrier L's business grows. For carriers like L to compete in the 5G era, they require storage to meet their high performance, high reliability, and high scalability requirements. OSS provides operational support for telcos. Since new sites need to be added in hotspot areas during 5G network deployment, the NE density of 5G is 1.25 times that of 4G. The number of KPIs of each NE increases 1.2 times. This leads to a 50% increase in basic OSS data volume. As the number of NEs increases, automated O&M becomes an inevitable requirement, and the more data is required for automated network planning and optimization. The CHR data sampled for each NMS increases from 100 gigabytes per hour to 275 gigabytes per hour. In addition, post-analysis is changed to pre-analysis, and the storage duration increases from 7 days to 90 days. Based on this 2.75-fold increase in data traffic, multiplied by the expected 12.8-fold increase in data storage duration, we can expect CHR data volumes to increase by 35 times. In this example we have of Carrier C, we can see that the OSS data volume will increase by 8 times, which leads to the requirement for storage resource pooling capabilities and effective and efficient resource provisioning, operation, and maintenance. This means that the storage silos must be replaced by a resource pool which allows resource utilizations to be increased from today's less than 50% to more than 70% and increase Carrier C's flexibility. In addition, continuous NE capacity expansion takes about 3 months. Therefore, the capacity expansion efficiency needs to be improved and allow the time to market to be shortened. Adopting SLA-based automation can bring those months down to just hours or even minutes, making Carrier C more agile. This means that automated O&M is also required to accelerate the efficiency, keeping operational costs under control and increasing service reliability. In the 5G era, video will become a major revenue source for telcos. Let's look at Carrier M as an example. This company has adopted the Internet plus digital content strategy to increase revenue. Video is evolving from HD at 1080p to Ultra HD at 4K and VR. An hour of 1080p video requires about 5 gigabytes of storage capacity, whereas in 4K, that same video would require 15 gigabytes of storage capacity, and as a VR, that video would require 180 gigabytes. According to the UHD capacity plan and user development program of Carrier M, their video capacity demands will increase from 15 petabytes to 152 petabytes over a 5-year period. And the total data transfer volume will also grow by more than 10 times. However, their revenue over this same period is projected to rise from $6 billion to only $10 billion. That's just an increase of 66%. Therefore, their data infrastructure must support large-scale expansion within a small footprint in the data hall and come with a significantly lower TCO per capacity in order to be successful in their Internet plus digital content business plan. As the data volume in the production domain increases, including BSS, OSS, other business systems, and third-party data sources, the data volume involved in big data analysis soars. The value within the data available to telcos is only beginning to be realized, and much of the data has yet to be tapped for value. The data being made available for big data analysis will be increasing as the potential for benefits from these other sources of data are realized. In addition, to unleash more data value, the data storage period also must be prolonged. In many cases, the data analysis period is increasing from 1 month to 3 months or even 6 months. Let's take Carrier T as an example. In 2019, their storage capacity for big data analysis was 35 petabytes. They estimate that by 2021, this year, their big data capacity requirements will increase by almost 5 times to 160 petabytes. A 5-fold data growth requires high scalability of data infrastructure and support for multiple services. In addition, big data applications are gradually becoming production applications, meaning analytics data now needs to be as reliable as any other mission-critical data, and it must meet all other requirements and expectations for production data. AI applications have been widely used in various industries for functions such as intelligent chatbot services and digital marketing for telcos, and financial fraud prevention for banks. AI applications cannot be successful without the training and verification from a large amount of data. This data must be curated and prepared before analysis of its content can begin. Operations such as data collection, sanitization, and loading require high write bandwidths and the ability to store information at gigabytes per second levels. Model training needs high random IOPS capabilities, each with millisecond level read latencies, to complete thousands of iterations of calculations and optimizations. A model verification and evaluation phase additionally needs multi-phase data access to tune parameters, create inferences, and support insight development. Finally, both raw source data and training data sets need lifecycle management, including backup and archiving of data and models. Analytics and AI applications are our second IT domain. And as we have seen, they require a data infrastructure with high bandwidths, low latency, multi-protocol convergence, and intelligent tiering of hot, warm, and cold data. Business agility is critical for innovative services. The traditional waterfall development model cannot meet the requirements of business agility today. Currently, we follow the golden 20-day rule, which compels us to complete multiple iterations and service releases within a short period of time. Project schedules that used to span months or even years are now expected to roll out products in days or even hours. Cloud native has become the de facto standard for agile enterprise architecture and a key technology to DevOps and continuous delivery capability. Cloud native development depends on container technology and, in most scenarios, distributed databases to store status information. Innovative services requires an infrastructure that can support this rapidly changing environment. Cloud native architectures, container technology, and distributed databases. These data infrastructures must be highly reliable, often with 24/7 online operating requirements and demand for geo-redundant 3 data center disaster recovery solutions. These are, after all, enterprise applications and cannot compromise on quality for the sake of agility, but rather push the storage infrastructure to new levels of reliability, performance, flexibility, and efficiency. Again, the ability to manage operations in such a rapidly changing environment requires high levels of automation and autonomous enforcement of SLAs. In addition, Cloud-native applications also need to support smooth migration to and from public clouds. A huge amount of data drives the development of high-performance computing. Telcos can take advantage of high-performance computing as a new opportunity for business services, serving industry applications such as genome sequencing, remote sensing, oil and gas exploration, and automated driving. HPC has shifted toward high-performance data analytics, or HPDA, and HPC-based AI convergence. The growth of HPDA and HPC-based AI is much faster than that of traditional HPC. The challenges of HPC for data infrastructure lie in hybrid workloads, where both high IOPS and high bandwidth are required, as well as data security, reliability, and data governance. So to summarize, we face challenges in every domain: production, analytics, and innovative services. These challenges arise from the increasing rate of data growth and growing business agility needs. Key requirements for storage, including high performance, reliability and scalability, resource pooling, effective resource provisioning and large-scale expansion, multi-service support, SLA-based automation, and data mobility, migration, and tiering, including support for the public cloud. We suggest that there are three major objectives which embrace these requirements and can satisfy many of your storage needs. First, we need to build a converged storage resource pool that can support multiple services, each with high performance, such as less than 1 millisecond latency and 6 nines of reliability. Second, we require highly automated, intelligent data management to allocate storage resources based on service level agreements and implement data mobility on demand. Finally, we need to open data services toward the cloud. Multiple deployment models such as edge, data center, private cloud, and public cloud can coexist for long periods of time. So we must support smooth evolution between these development models while supporting a wide variety of agile business needs. I hope you found these brief insights on telco IT data infrastructure useful. Thank you for listening, and please enjoy the rest of your summit.
Thanks to Mr. Kendall Chilton for a brilliant presentation. The next presentation today is from Mr. Huang Cong Liang, President of Huawei Global IT Products and Solutions Sales Department. His topic is building data-centric converged storage solutions for all scenarios. Please welcome to the stage Dr. Huang Cong Liang.
Good day, ladies and gentlemen. My name is Huang Cong Liang. I'm responsible for Huawei Global Storage Solution Sales. As mentioned by Ken, in 3G and 4G era, carriers were network providers for traditional voice and data service. Now, innovated to be an IoT applications bring carriers with opportunities to expand business scope because they have the most comprehensive digital infrastructure. Therefore, carriers will move from network providers to collaborative network, cloud, and AI providers. As a vendor that have full-stack network, cloud, and AI infrastructures with industry experience, Huawei will continue to work with carriers to build intelligent, converged cloud and AI infrastructure and help carriers to expand their business scope and take the lead in the 5G era. From data storage point of view, we need to focus on the following three aspects. First, carriers increase service type by 2 to 3 times, providing hundreds of services in total. Therefore, they need a converged storage pool to support multiple services. Second, the rapid growth of service types and quantity will increase carriers' data center size and bring the challenge to data management. So, an intelligent data management system will be required by carriers. Last but not least, diversified service type and business models require collaboration on cloud, off cloud, and the edge. Thus, resource collaboration and data mobility is a must. Thus, Huawei provides the all-scenario converged storage solution, designed to help carriers to build a 5G-oriented intelligent storage platform. The solution delivers a converged storage solutions pool to meet different SLA needs, using diversified hardware and unified software. It uses the data management platform with 3 layers intelligent capabilities to provide highly automated management, helping carriers automatically provision storage resource and enable on-demand data mobility and tiering. This will increase storage O&M efficiency by 5 times. Additionally, the solution adopts a fully open architecture to offer cloud-ready, open data service. This means that it supports multiple deployment modes and enable data mobility on and off the cloud. Let's first talk about the multi-service converged storage resource pools. Huawei provides diversified storage devices for different service and data lifecycle phases. For example, Ocean Store Dorado for core production service like BSS, Ocean Store Pacific for emerging mass data service like file sharing and object resource pool, Ocean Protect for backup and archiving. The most important thing is that the diversified hardware are built on unified software platform Ocean Store OS. Ocean Store OS converges data and provides unified management and data mobility across device types. It also delivers a converged storage resource pool with high performance, reliability, and scalability. Now, let's talk about Intelligent Data Management, Huawei DME. It is an intelligent management platform oriented for full lifecycle of data storage. Based on the unified management of storage subnets, it delivers intelligence to 3 core scenarios. The first is intelligent data tiering. It uses a workload fingerprint-based technology to detect service and precisely match service SLA to storage tiers, thus improving storage resource efficiency. The second is intelligent data mobility. It centrally manages all storage in a data center. Based on that, it sends data activity dynamically and allows each byte of data to move freely on demand without impacting service. This minimizes the TCO for customers throughout the data lifecycle. Finally, intelligent O&M with the capability of intelligent prediction. DME can predict performance, capacity, and faults in advance, turning passive into proactive O&M. Let's take Carrier T as an example. To ensure zero error during the service change, the engineers spend hours preparing scripts. 5 engineers have to stay up all night in case anything goes wrong. With Huawei DME, the service change efficiency improved by 60% while reducing the required staff from 5 to just 1. The final one is cloud-ready open data service. Coexistence of multiple clouds has become the new normal. Edge, data center, and the public cloud has their own application scenarios and will coexist for a long time. So, how to adapt to a multi-cloud environment is a key challenge for any enterprise. So, how to adapt to a multi-cloud environment is a key challenge for any enterprise. Huawei's all-scenario converged storage solution support deployment in various modes, provide on and off cloud data mobility and smooth evolution. Ladies and gentlemen, today I'm glad to unveil the One Storage solution. The solution provides converged storage resource pool, intelligent data management, and the open data service, enabling both carriers and enterprise to achieve all-scenario intelligence and multi-cloud convergence. We look forward to working with our customers and helping them transform toward a digital intelligent future. Thanks.
Thanks to Mr. Huang Congliang for an inspired presentation. The last presentation today is from Mr. Zhang Fupeng, Vice President of Huawei IT product line. His topic is Huawei Ocean Store, innovations towards all-scenario converged storage. Welcome, Mr. Zhang Fupeng.
Hello, everyone. Thank you for listening to this session about innovation towards all-scenario converged storage. I'm Alex Zhang from Huawei IT product line. Nowadays, a lot of enterprises is doing digitalization to make sure that they can do a better business in the digital future. For this one, in the IT technology itself, we have a lot of thinkings. The first one is that we must build a good resource pools. In this case, we can provide the capability for different types of services, while we can do the resources pooling that make sure we have just provided the better and filterable resources. But when the data is becoming more and more, we need the intelligent data management for this massive data increase and the complexity to make sure that we have a better performance, efficiency, and lower cost. And in future, we will have different types of service applications. So make sure that we should satisfy current on-premise types of solution, but also capable to support in future the private cloud and the public services. All this kind of application must be capable to be served by the one unified data storage foundation. So today I will share with you Huawei Ocean Store, how to embrace a digital future with one storage solution. We have Huawei Ocean Store storage products, and also we have the data management engine. With these two, we can provide this kind of one storage solution for our customer. We have already been known as the main storage vendor because of our star products. For example, the Ocean Store Dorado. It is for the mission-critical data storage. But also we provided the market with the Ocean Store Pacific. It is for the large-scale unstructured data. So it's a distributed storage. Beyond this kind of main storage, we also provide you the data protection solutions. We call it Ocean Protect. These are our star products. How we can satisfy you these kind of product and solutions? We cannot just offer you products in a silo model. We also need a very comprehensive design, innovative design to support different kind of requirements in the future. We can support the diverse hardware platform to provide you the high performance, high reliability, scalability, and reliability. On this one, we need to build a unified software to capture this kind of difference between hardware. And then on top of that, we need the innovative architecture to satisfy different kind of application and app-layer solution requirements for innovation. So today I will introduce you different kind of solutions from us. The first one is the Ocean Store Dorado offline storage. We are now shipping these cutting-edge products worldwide. We have the most leading performance is 21 milliseconds of IOPS. And also, it is low latency to 0.05 milliseconds. This is a further improvement on top of our 0.1 milliseconds when we released this product in 2019. This is already improvement compared to that. And also, we have the most powerful reliability. We have a 7 nines of reliability. Compared to the industry, it's mainly 6 nines level. It is much beyond the industry level. Not only for this kind of high-value structured data, we all know with the AI technology is developing, we need more and more unstructured data. So we'll provide the OceanStor Pacific series storage to make sure that we can host this massive unstructured data with an optimal way on the cost effectiveness. So it can reduce a lot of cabinets, saving a lot of spaces, saving a lot of storage spaces because of the data reduction and because of the high density of the hardware design. This is 20% lower cost per bit we estimated to provide it to our customer. But not only this kind of main storages, we also provide these full lifecycle solutions. In this case, it's not only the production with OceanStor Dorado and the analytical application with OceanStor Pacific. We also need for the backup and archive solution. We call it the Ocean Protect. So in this case, we can host the hot data, warm data, and cold data in a more proper way. We build the solid data store foundation with end-to-end application. But we could not just provide the product. We give you one converged foundation. So we build this OceanStor OS to be the software platform for all these kind of products. It can host diverse hardware matching, different kind of computing power, different kind of network solution like a fiber channel, IP, or different media with a hard disk, solid disk, and also the storage class memory. It can provide you the high IOPS, it can provide you low latency, it can also provide high performance, but with strong reliability. How we can do this one? We need the innovative architecture. For example, on the high performance, we have the flash link technology. It can have this kind of end-to-end computing power. It's not the computer is not only on this controller itself. It's also on the SSD array disk enclosures. Also, in this kind of each disk itself, SSD disk itself. So with the end-to-end computing power, it can know the data format inside to have end-to-end performance optimization to make sure there's no performance bottlenecks. And based on this powerful processing capability, we can offload a lot of processing workloads from controller to the SSD itself. And then we build the end-to-end NVMe architecture, can provide you the 30% lower latency. And not only this one, we also build the AI algorithm to make sure that we have higher caching ratio to make sure different kind of scenario we have the best cut-in performance. Beyond this product itself, we can also need to focus on the data center level. So the data transmission, we have the joint innovation with Huawei Cloud Engine team. So this NVMe over RoCE technology, we can build the latency to the 50 microsecond level. So in this case, we can bring 58% lower latency and 2 times more IOPS. So it's a further step. On reliability, we build the world's most powerful reliability. It is with smart matrix architecture to the 9/7 reliability. It is because within the 8 controllers, we can tolerate up to 7 controllers failure. With different controller enclosures, we can tolerate 1 controller enclosure totally failure. So in this case, we can have the minimal fault domain and have the global load balancing to make sure that you have reliable foundation of data. Not only on data center level, we also need more reliability between the data centers. So Huawei has the true active design with the hypermetro design. So data center 1 and data center 2 is all active with applications. But when there is a failure, the service level application active high reliability can make sure that there's 0 service interruption or data loss. These kind of distance are even up to hundreds of kilometers away between the data centers. It can have the automatic failure recovery. So the application level has no impact because of this. And high scalability is another checking point. So we have the distributed software architecture. Compared to the previous, we must build different kind of scale out for different kind of services like blog, file, object, big data. We have one unified global storage pool. So we can bring all these different kind of workloads on one storage pool. And so in this case, we can do hybrid workloads. So to make sure that we are easy to use, and then this one can be easily scaled out to about 4,000 nodes per cluster. So in this case, we can build to satisfy the data expansion requirements. Not only for the storage itself, in the data center level, the storage must work together with computing resources. Previously, when you need to have the bottleneck on the computing or storage, you must scale out the whole resources because it is a coupled design. But right now for the data center, we believe the decoupled storage and compute architecture will build an elastic data platform for all the customers. Why? It is because the computing technology, which is more based on CPU, NPU, the computing technology, it is only have 3 years life cycle. But the storage part, because of data life cycle, it's very complex. We many of time have 5 years or 10 years life cycle. So we must expand the storage and the compute because separately because of the life cycle differences. But also, we need to eliminate the restriction that the expansion must be done together. The one there is a computing demanding application. We can expand compute resource easily. When there is a storage demanding application, it should expand the storage separately, not in a coupled way. Even if we need to upgrade our storage, Huawei open source solution has one design. We call it the flash ever. So in that means we can upgrade the storage separately by the controller enclosure and the disk enclosure. In this way, when we are upgrading controller enclosure, the disk enclosure is not touched. So the data itself, no need for the service interruption or data migration. If we upgrade the disk enclosure and then the controller enclosure will have the data in reconstruction automatically. So in this way, there is migration free of the solution for 3 generations in 10 years. So it's hugely reduced the complexity of the data migration scenario. We have all this kind of product solution itself, but not many of time we need to manage this platform in a more easily way. So we build a highly automated with 3-layer collaboration intelligent data management platform. We build the AI capability in the device level, in the data center level, and in the cloud level to targeting the intelligent data tiering to make sure we have a pool for the storage resources. And also to do the intelligent data mobility, it is to satisfy a lot of scenarios. It's driven by services difference, data protection requirement, user experience requirement, and the cost requirement. And at the end, we need to improve the intelligent data O&M efficiency. The first one, intelligent data tiering. We can put all different kind of storage into a pool. But it's very hard to understand from the different kind of application in which tier it goes to, what kind of SLA it requires. So the DME have the capability to build in the workload identification. Based on this kind of automatic identification, it can do a better workload clustering. With the clustered workloads, it can meet into the different kind of tiering, and then the DME will automatically put this data storage into the corresponding storage products. Either it is mission critical for Ocean Store, Dorado, or Flash, or it is massive unstructured data on the Ocean Store Pacific, or it should be in this backup or archive. So it's all automatically done. So the TCO will be 30% optimized. It can do the resource aggregation and sharing. Many of the time, the utilization ratio is 40% in the carrier IT platform. But right now with this DME, it's proven will be 70% of the resource level. That is tiering and the pool. But there is a way to optimize how we make the data storage. We should put the data into the most suitable storage itself. Then we have different kind of floating requirements. Either it is life cycle driven, because it is from old legacy storage to the new storage, or it is driven by the business process. For example, the video surveillance data from edge to the center, or it is Telco's prediction, precise marketing needed the data from BSS domain into the data analysis domain. And also, there is a business protection driven requirements. It's a snapshot, local backup, intracity active design, 3DC data recovery, this kind of thing. Even better way, we want it is user experience driven or cost driven. When some of the data is no longer hot anymore, we want to put it into the backup or archive. So this is cost driven. So with the intelligent data mobility, we can do the better efficiency utilization than to make sure that the DME can help this kind of data flow more easily. And for the intelligent data mobility, it also have one very typical way is that operation migration. In the migration, it's very complex and heavy job for the maintenance people. We need to evaluate, we need to plan, we need to implement and check. But with this kind of DME support, with the infographic tools, migration design tools, we can do 90% of efficiency improvement. And this is for the daily operation. But how about the fault management? If the data is increasing 10 times more, 5 times more, how can manage? So we must utilize this DME to optimize it. So right now, we have the capability to support people, one person to manage 50 sites of storage compared to previously only 10 sites of storage per person. Because it can do the disk fault prediction 40 days ago ahead. Performance trend prediction 60 days ahead, and capacity trend 1 year ahead. This is to improve the efficiency. In future, the enterprise digitalization will have multiple application scenarios. It could be on-premise with this virtualization based on VMware virtualization or OpenStack. It can be also a new technology like Docker. And also we need to leverage the public cloud application. So this story must have the one framework to fit in multi-cloud scenario. So this is also part of our capability. We can have the standard interfaces toward different kind of application. So we believe with these innovative products and also with the intelligent data management, we can provide you the cutting-edge solution. So we have already more than 8 years R&D in this domain, and right now we have been well known because of our R&D innovations. We are recognized by the third party to be a global data storage market leader. So we hope that we can have the opportunity to cooperate with you together. Till now, we already have 12,000 global customers. We believe with your support, with our continuous R&D, we will embrace the digital future together. Thank you for your time.
Thank you, Mr. Zhang Fu Peng, for an excellent speech. This concludes all of our presentations. Thank you for joining us. If you want to watch a playback of today's keynotes, just sign in. Please stay safe, and we hope to see you next time.